Okay, we have here today another interesting integral from the Unsw integration bee from 2023. This one's problem 3. We have the integral of 2x plus 3 over x squared minus 9 dx. Okay, at first I was thinking maybe we could do a u substitution here, making the u the whole denominator, just because when you take the derivative of this, you get the 2x, but you don't get the 3. Now that's fine because we could split it into two integrals, but then on the second one, we'd still have to do partial fractions. So my thinking is let's just go directly to the partial fractions. But this is a difference of two squares. I can just factor this as x plus 3 times x minus 3. So now for partial fractions on this, we can actually use the cover-up method. I'll just write down this fraction, but I'll write it with the denominator factored as x plus 3 times x minus 3. And then we'll break it up. Over here, we'll write it as a over x plus 3 plus b over x minus 3. And so we just want to find these two constant values, a and b. So first, for the cover-up method, what I'll do is look at this term here, figure out what's going to make it 0. We can do that with minus 3, but we don't want to actually divide by 0, so we cover that up, plug the minus 3 in everywhere else. So when we plug this into the numerator, we're going to get 2 times minus 3 plus 3, and then plugging minus 3 in here, we're going to get minus 3, which is minus 6. And then if we just simplify this fraction, this is going to become 1/2. And then we'll just write that in for our a value because the a value is associated with this term that we made 0 here. Next, we'll do the same thing for our b term. We just need to look at this second piece associated here, right? We just need to look at this second part, x minus 3. What's going to make this 0? Well, that's going to be 3. We'll cover that up and we'll plug the 3 in everywhere else. So doing that in the numerator, we're going to have 2 times 3 plus 3. And then plugging this 3 in here, this is going to be 3 plus 3 or just 6. Multiplying this out, we get 6 plus 3, we get 9 over 6, and we can reduce this to 3 over 2. And that's going to be our value for b. So now let's just take what we found here, plug it back into the integral, but because we have two terms now, we'll split this into two integrals, and then we can finish it off. Okay, so now that I've rewritten this, we have our a value here and our b value here, so we're all set up to integrate. We've got two pretty easy integrals. And of course, we could bring the constants out front in each integral, but it's going to work the same either way. So let's just go ahead and integrate this. So for the first one, integrating this, we'll have 1/2. This is going to become natural log absolute value x plus 3. And then for the second one, we're just going to have our 3/2 in front, and this is going to become natural log absolute value x minus 3. Add a plus c on the end, and that's going to be it. Okay, so there you have it. Pretty straightforward problem from UNSW 2023. Thanks everyone for watching today. Have a good day.